Let's talk about quadratic functions today. First, we'll define what a quadratic function is. This is a function of degree 2 with a non-zero leading coefficient. It has the form f of x equals ax squared plus bx plus c. Now the reason a cannot be 0 is because if a were 0, then it'd be 0x squared, leading this to just be bx plus c, a linear function instead of a quadratic function. With that out of the way, a couple more points here. Quadratic functions have a U-shaped curve. We call this a parabola. Sometimes this will open up and sometimes this will open down, depending on whether if a is positive or negative. All parabolas are symmetrical about an axis of symmetry, and the point of intersection between the axis of symmetry and the parabola, we call this the vertex. So here's some basic characteristics of quadratic functions, but as we can see, let's just skip down to the graph here. Sometimes they will open up like this and provide a U-shaped curve. This is when a is positive, and sometimes they will be upside down, and this is when a is negative. When a is positive, this vertex is going to create a minimum, since that's going to be the lowest point on the graph. And when a is negative and it opens downward, the vertex is going to create a maximum, since that's going to be the highest point of the graph. And speaking of graphs, let's just take a look at a few of them. So what I've done here, this grayed out portion, this is the parent function, just f of x equals x squared. Well, let's take a look at how this compares to a couple of ones that have had some transformations done. So the bold black one here, this is g of x equals negative x squared plus 1. The plus 1 at the end indicates that we're going to move the vertex up 1 point here. And then negative at the front for a, this means that we're going to take this and do a reflection vertically, so it's going to reflect this and make this open downward now. And when we compare these two, again, the grayed out one, this is just our parent function, f of x equals x squared. And this black one, that's a little bit more bold, this is h of x equals x plus 2, and then that whole thing squared, minus 3 at the end. Well, as we can see, our vertex went from 0, 0 to now negative 2, negative 3. Compared to h of x, where do we see this negative 2 and this negative 3 popping up? Well, I see a 2 here and I see a negative 3 here. So that means that these have something to do with how we graph this and where to put the vertex of our parabola. Let's take a closer look. This is the standard form of a quadratic function. F of x equals a times x minus h squared plus k. Now this is particularly useful for sketching these parabolas because the axis of symmetry is x equals h. Note here x equals h, but in our standard form this is x minus h. And the vertex is the point hk. And as we had mentioned before, when a is greater than 0, so when a is positive, the parabola opens upward. And when a is less than 0, or when a is negative, the parabola opens downward. Now you may need to complete the square. This is something that we did in an earlier class to write the quadratic in standard form. Let's do an example of that. Describe the graph of f of x equals 2x squared plus 8x plus 7 and identify the vertex. Okay, as is, this is one of those that without some kind of graphing utility, such as a calculator or Desmos, this is going to be hard to graph. So what I need to do is first get this into standard form so I can get a little bit better idea of how this is going to look even without making a graph itself. So here's how to do this. First, we're going to group the x terms together. So I've got 2x squared plus 8x here, and I'm going to put those together first. And then I'm going to have the plus 7 still out here. Then I'm going to factor this if I can. Here I've got a 2 and an 8, so I know that these are both even. I can pull a 2 out to the front. All right, now the important part. What I want to do is inside of these parentheses, I want to add and subtract b over 2 squared. Now, what is b? In this case, b is 4. So what I want to do is I want to do everything remains the same. 2 times, and then the quantity x squared plus 4x. Except over to the side now, b is 4, so this is going to be 4 over 2 squared. 4 over 2 is 2, so this is going to be 2 squared, or 4. I want to add and subtract 4 inside of the parentheses here. And I still have plus 7 at the end. The reason I did this is so that this part right here, x squared plus 4x plus 4, this is something that I can factor. This is a perfect square trinomial. And what I'm going to do with this negative 4 is I'm going to recognize that this 2 on the outside is going to distribute to every term on the inside. And I'm going to say 2 times x squared plus 4x plus 4. And I'm going to break this up and say plus another 2 times this negative 4 plus a 7. What this allows me to do is, because this is a perfect square trinomial, I can factor this to x plus 2. And this is squared. Here, 2 times negative 4 is going to make negative 8, and then plus 7, so I'll have minus 1. The standard form for the same function here, 2 times x squared plus 8x plus 7, is this: 2 times the quantity x plus 2 squared, and then minus 1. So this is my standard form. And what does this allow me to do? Well, this tells me that because a is positive, the graph will open upward. And I also know that here, the regular standard form is x minus h. Because this is x plus 2, I know that h is negative 2, and that k here is negative 1. So my vertex is going to be the point negative 2, negative 1. Other things I could say, this is going to have a downward shift of 1 relative to y equals 2 times x squared, and then I'll also be moving this over to the left 2 spaces as well from the origin. Let's do another one. Let's find the standard form this time of x squared plus 8x plus 11. Here I want to identify the vertex and the x-intercepts. So again, this is one of those where, as it is, it's kind of hard for me to do that. So I'm going to try and complete the square and get this into standard form. So first, grouping the x terms together. X squared plus 8x together. And then I'm going to have a plus 11 out here. All right, b over 2 squared this time is going to be, I've got 8. So this is going to be 8 over 2 squared. 8 over 2, that's 4 squared, which is 16. So I'm going to be adding and subtracting 16 inside of these parentheses. x squared plus 8x. And then here, this is where I'll add and subtract 16. And then I've got plus 11 on the outside. All right, now this is a perfect square trinomial. And because I don't have anything that's going to distribute, I can just move the negative 16 to the outside now. So this is going to be x squared plus 8x plus 16. And then I'll have, moving this outside, minus 16 plus 11. This allows me to factor this perfect square trinomial to x squared plus 4. Oh no, I'm sorry, x plus 4. And then square this whole thing. And then minus 5. So the graph will have a vertex at -4, -5, since h equals -4 and k equals -5. Now to find the x-intercepts, what I'm going to do is set this equal to 0. So let's do this down here. X plus 4 squared minus 5. I'm going to set this equal to 0. And let's find where the x-intercepts are going to take place. We're going to add 5 to both sides. So this will be x plus 4 squared is equal to positive 5. I can then take the square root of both sides. The square root and the square, these are going to undo each other, leaving x plus 4 is equal to, and then remember on this side, I have to do positive or negative square root of 5. Now subtracting 4 from both sides. This will give me x equals -4 plus or minus the square root of 5. Then the last thing I can do here is find the standard form of a quadratic function with the vertex -4, -1, and passes through the point -2, 4. Okay, so let's first identify a couple things. If the vertex is -4, -1, that means that h is -4 and k is -1. And since we're passing through this point -2, 4, then I can treat this as x and y, or x and f of x. So we'll start with my standard form. Okay, standard form here is f of x equals a times the quantity x minus h squared, and then plus k. Well, if I know that h is -4 and k is -1, then I can plug those here and say f of x equals a times x minus -4, so this will be plus 4 squared, and then plus k, k is -1, so minus 1 here. And if I know that x and y, it passes through this point, -2, 4, then I can also plug those in. So instead of f of x, I can say this is 4 equals a times x is going to be -2 plus 4 squared minus 1. Okay, so -2 plus 4, this is positive 2 here, so 4 equals a times 2 squared minus 1. 2 squared is 4, so 4 equals 4 times a minus 1. We'll add 1 to both sides. And we get 5 equals 4a. Let's divide both sides by this 4 to solve for a. And this will give us a equals 5/4. Now, the reason this is helpful is because my standard form, let's go back up to this, is f of x equals a times quantity x minus h squared plus k. So since I already had the vertex, -4, -1, which implied that h equals -4 and k equals -1, the only thing I was really missing was a. But now that I've found that a equals 5/4, I can say the whole function in standard form is f of x equals 5/4 times the quantity x plus 4 squared, and then finally minus 1.